Hello friends, this is Brajesh Kumar Jha and you are watching the video series on engineering mathematics. So in this section, I will talk about questions that are asked in the GATE examination. So the topic that I have selected for today's discussion is complex analysis, and in complex analysis we will talk about the complex number. So as we know, the complex number is initially we have to study complex number, then we enter into the complex analysis. But the number of easy questions are asked related to complex number. So first 10 questions that I have selected for today's discussion. Question number 1 to 10. Definitely they are easy questions, but if you watch, that will encourage you to sit in the GATE examination. So let's start the topic, that is complex number. So basic of the complex number that you must know, once we write z is equal to x plus iy, so that is the complex number. If you are new, then subscribe our channel for more updated videos and questions related to GATE examinations. Like it and share with your friends. Okay, so let's take the first question of today's discussion. Very simple question that I have picked. If a complex number z is equal to root 3 by 2 plus I 1 by 2, then we have to find the power z to the power 4. So this is the example z to the power 4 that is required. In place of any number can be written, right? So the options are 2 root 2 plus 2i, minus 1 by 2 plus I root 3 by 2, root 3 by 2 minus I 1 by 2, root 3 by 8 minus I 1 by 8. Okay. So in such a condition, if it is asked in such a way, z is equal to a plus iv, let's say. So first what we do, we have given z root 3 by 2 plus I 1 by 2. So it can be written as in the form of trigonometrical function. So root 3 by 2 is what? Cos pi by 6, cos 30 degree, plus I sine 30 degree. So this, okay, either you can move to the de Moivre's theorem or you can convert it in the form of e to the power I pi by 6. So first way, it is e to the power I pi by 6 that you can write. So z to the power 4 will be, either you can write cos pi by 6 plus I sine pi by 6 power 4, or you can write e to the power I pi by 6 and power 4. So here, by using de Moivre's theorem, you can write cos 4 pi by 6 plus I sine 4 pi by 6. And this way you can also write e to the power r 4 pi by 6. Both are the same. So it can be written as cos 2 pi by 3 plus I sine 2 pi by 3. So you must know the values of this cos 2 pi by 3 plus I sine 2 pi by 3. So what we see, the value of cos 2 pi by 3 is what? It is minus 1 by 2. And plus I vata sine, value of sine 2 pi by 3 is what? Root 3 by 2. Okay. So this is the required answer. So what we can see, option B is the correct answer. So these questions are very good questions you can solve in the GATE examination. So in the place of z to the power 4, if it is written any value, z to the power 6, z to the power 10, whatever, that you can solve. Okay. Now come to the next question. Here I is equals to square root of minus I, then one value of I to the power I is, that we have to give the answer. So in that case, what we can write here, I to the power I. So first we check the option. Option A is root I, B is -1, C is pi by 2, and D is e to the power minus pi by 2. So what we can write here, so we suppose that let y is equals to I to the power I. So I in the rough work I can write I is what? It is 0 plus I into 1. So actually it is what? It is e to the power I pi by 2, because cos pi by 2 is 0 and sin pi by 2 is 1. So it can be written as e to the power I pi by 2 and power I. Okay. Now what we do here, we take the log both sides. So log y or ln y that we can write, and it will be log e to the power I pi by 2, and this power I that we can take this side. So it will be cancelled here. So log y is equals to what? I into I pi by 2. So finally it is going to be log y is equals to minus pi by 2, or we can log y, and y is equals to e to the power minus pi by 2. Here also we can check directly y is equals to e to the power I into I pi by 2. So y is equals to e to the power minus I square is the -1, so minus pi by 2. So and the way you can represent, so this is the first way, this is the second way, both are way to represent your answer. So what we see, what which value is the correct answer? So D is the right answer. So D is the right answer. Okay, so next easy question is what? The value of expression that we have to find. So it was asked in the GATE 2008. So -5 plus I 10 upon 3 plus 4I. Options are 1 minus 2I, 1 plus 2I, 2 minus I, and 2 plus I. So very easy to solve these type of questions. What we do, we write z is equals to -5 plus I 10 upon 3 plus 4I. Only things is to do here, we rationalize this complex number. So it will be -5 plus I by 10 upon 3 plus 4I. And how we rationalize? By 3 minus 4I, the complex conjugate number that we take of the denominator. Okay, so it will be multiplication of these two. So once we have to multiply the two complex number, so it is very easy to write in such way. First multiply real and imaginary both. So -5 into 3 is -15, and 10 into 4 40, and minus I square will be -1, so minus minus plus 1, so plus 40 it is, plus I. So it is 10 into 3, that is 30 that we can write, and real and imaginary. So it will be plus 5 4 are 20. Divide by, it will be a minus b square. So it is a square, that is 3 3 are 9, and plus 4 square, that is 16, because I square is -1, so that makes the plus sign. So it will be what? It will be 25 plus I beta 50 upon 25. So finally it is what? 1 plus 2I. So this is the required answer. So in the option that we can see, the option B is the correct answer. Okay, so very quick, we come to the next question. The question was asked in the GATE 2009, the product of the complex number. So it is very easy to write. So z is equals to 3 minus 2I into 3 plus 4I. So how we multiply? First real and imaginary that we multiply. The 3 3 is 9, and 2 into 4 8, I square is there, so plus 8 that we can write, plus I real and imaginary that we multiply. So 3 4 is 12 and 3 2 is 6. So it is what, 9 plus 8 that is 17 plus I beta it is 6. So your answer is 17 plus 6I. These type of questions were asked in the GATE examination. Okay, come to the next question. Okay, so very quickly we reach to the question number 5. So z is equal to x plus iy is given and we have to find the value of mod of e to the power iz. So in the place of e to the power iz, it can be written e to the power minus iz minus 2iz plus 2iz like that. So first check the option here. A is 1, option B is what, e to the power square root of x square plus y square, e to the power y and e to the power minus y. So how we check this solution? So first we write here, let's say f is equal to e to the power iz. So it will be what, it will be cos z plus I sin z that we can write. So z is what, you know, z is equal to x plus iy that we know. So in that case it will be cos x plus iy plus I sin x plus iy. So do not do the mod of this one, it is cos square z and plus sin square z, it is 1. So this is the misunderstanding here. So in that case this will be written as cos x plus iy. So it will be what, cos x into cos iy minus sin I into sin iy plus I sin x plus iy. So it is sin x cos iy and plus cos x sin iy that we can write. So we must know that sin I theta is I sin hyperbolic theta. So that relation between trigonometrical function and the hyperbolic function that you must know. And cos I theta is what? It is simple cos hyperbolic theta. So in that case your f will be cos x, cos iy will be cos hyperbolic y minus sin, this would be the sin x. So it is sin x and sin iy will be what? I sin hyperbolic I sin hyperbolic y plus I. So it can be written in the same way, sin x and cos hyperbolic y and plus I cos x cos sin hyperbolic y. So from this result what we get here, from this one cos x and cos x that we have taken common, so it will be cos hyperbolic y minus sin hyperbolic y, because I into y will be minus 1, and plus I sin x if we take common, so it will be cos hyperbolic y minus sin hyperbolic y. So as we know here, the cos hyperbolic y minus sin hyperbolic y, it is e to the power minus y. So your f will be e to the power minus iy and cos x plus I sin y. Now if you take the mod value of f, so it will be 1 and it will be e to the power minus iy only, into 1 that we can write e to the power minus y. So your option D is the correct answer. So this is the one way to solve. I will sharing here the another way to solve this question. So another way we can write here. So we have asked here to find the value of e to the power I mod of e to the power iz. So that can be written as mod of e to the power I x plus iy. So it will be what? E to the power uh, ix minus y that we can write. So this can be written as mod of e to the power ix into mod of minus y. Because you know mod of z1 into z2 is what? Mod of z1 into mod of z2. That property we have used here. So now e to the power I x, it is 1, as we have shown in the last slide. It is going to be cos x plus I sin y. So mod will be cos square x plus sin square x square root, and this will be e to the power minus y. So finally it is a bit, because it is the real one, so we have e to the power minus y. So option D is the correct answer. So I have shown here the both way. Whatever you understand, that you can approach. Okay, very quick. We come to the next question. Okay, so next question that we see on the screen, the augment of the complex number 1 plus I upon 1 minus I, where our I is square root of minus 1. So first we simplify this complex number. So we have given z is equals to 1 plus I upon 1 minus I. So it will be written as 1 plus I upon 1 minus I. So by rationalizing it, it will be 1 plus I whole square. So it is 1 plus I square plus 2I upon 1 plus 1. So I square is minus 1, so it will be cancelled. So we get 2I upon 2. So finally I. So this I can be written as cos pi by 2 plus I sin pi by 2. So augment of the matrix that we know, or other way, I can be written as, so pi by 2 that we can know the theta is what? Pi by 2. Here this also we can represent. Another way, I can be written as 0 plus I into 1. So augment of z is what? It is tan inverse uh, y by x. If you write here x plus iy. So again it is tan inverse 1 upon 0. That is tan inverse infinity. So in this way also we can see it is what? Pi by 2. So theta is pi by 2 that we have. So pi by 2 is the right answer. So option C is the correct answer. Now let's take the next easy question. Okay, so we come to the 7th question. So it was asked in the GATE 2010. If a complex number omega satisfy the equation omega cube is equal to 1. So this is the well-known equation. So omega is what? It is cubic root of unity. So what will be the value of 1 plus omega plus 1 upon omega? So we know, if you remember the cubic root of unity, so it is 1 plus omega square is what? 0. So that property we will use here. So we have given 1 plus omega plus 1 upon omega. So if you take the omega LCM, it will be 1 plus omega plus omega square plus 1. So it will be 0 upon omega. So your answer should be what? 0. So this is the right answer. So very quick, we go to the next question. The modulus of the complex number, this one. So in such condition, first we have to express this complex number in the form of x plus iy. Then mod of x plus iy will be square root of x square plus y square. So options are given 5 root 5, 1 upon root 5 and 1 upon 5. So we have given z is equals to 3 plus 4i upon 1 minus 2i. So first we rationalize this. So it will be 3 plus 4i upon 1 minus 2i and multiply with the complex conjugate of denominator. So it is 1 plus 2i upon 1 plus 2i. So by multiplying the real part, 3 into 1 it is 3l, 3 into 1 that is 3, and 4 into 2 that is 8. So it will be 3 minus 8. Okay, plus I, 4 into 1 that is 4 plus 2 into 3 that is 6. So it will be, okay, 1 minus 2i into 1 plus 2i. So it will be 1 plus 4. So it will be minus 5 plus 10i upon 5. So it is actually minus 1 plus 2i. So now mod z will be what? Modulus of 3 plus 4i upon 1 minus 2i. So it will be mod of minus 1 plus 2i. So it is square root of 1 plus 4. So it is square root of 5. So your correct option is root 5. Now the next easy question that we have, it is x is equals to square root of minus 1. Then one value of x to the power x is. So this question we have seen earlier also, but the options are different. So that's why we have talked about the two different ways to get the solution. So again, if you remember, I is equals to square root of minus 1. So we can solve in the form of I. So I is equals to square root of minus 1. So let's take y is equals to I to the power I. So I is what? It is cos pi by 2 plus I sin pi by 2. And it will be I. So it is e to the power I pi by 2 power I. So it is e to the power minus I. I into I, it is minus 1. That directly we can write e to the power minus pi by 2. So your correct answer is e to the power minus pi by 2. Now come to the last question, that easy question that was asked in the GATE examination. Square root of minus I that we required. So it is very interesting question that we can see here. So as you know, minus I can be written as cos minus pi by 2 plus I sin minus pi by 2. Other way you can write it here, it is cos 3 pi by 2 plus I sin 3 pi by 2. So by writing it, what we get here, okay, now it is, we have to find the square root of minus I. So square root of minus I is what? Minus I power 1 by 2. So it will be cos 3 pi by 2 plus I sin 3 pi by 2 and power 1 by 2. So using de Moivre's theorem, it will be cos 1 by 2 into 3 pi by 2. So it will be 3 pi by 4 plus I sin 3 pi by 4. So that can be also written as, so if you push here, cos minus pi by 2. So it can be cos minus pi by 4 plus I sine minus pi by 4. So both are the correct option. So your correct option is here, this one. So any one, option B is the correct answer. So both way that you can write. So in some question you may get only one option. So that conversion you must. So I hope so. These easy questions are refresh your basic idea regarding GATE examination. In upcoming lectures, we will talk about more questions related to complex analysis. So be with us. Subscribe our channel if you are new, if you have not subscribed yet, and comment on the comment box. If you have any query, you can write in the comment box, and you can join our WhatsApp group. So link is given in the comment box. Thank you.